All right, what we're going to do right now is we're going to do, as quickly as possible, a review of algebra, because we have seen some very scary algebra mistakes. Some of you have excellent algebra skills. However, I still have a few of you that are making some careless mistakes, and you guys are breaking the laws of math. And we all know what happens when you break the laws of math. You go to that's right, math jail. And we don't want you to go to math jail. It's no fun in math jail. There's no friends, and all the pudding is vanilla. If you like vanilla pudding, I guess it's not a problem. But chocolate is better. Anyway, so we don't want you to be in math jail. We want you to be out. We want you to be free. We want you to be free roaming young mathematicians out in the world learning and doing what you do best, which is growing as individuals and becoming awesome people. So we don't want you to go to math jail. And to avoid doing that, we are going to try to have an intervention right here, right now. So if we scroll back up, we're going to look at what I consider to be the golden rules of algebra. So while there are some other things that we need to know, for the most part, if you don't break any of these rules, you're probably doing okay with your solving of equations and whatnot. So of course, number one, we know whatever you do to one side, you must do to the other. That never changes. You can add any term to both sides of an equation. You can add 3x to both sides. You can add -2 to both sides. You can add 162 to both sides. It doesn't matter, as long as you do it to both sides, your equation will still be balanced. Likewise, you can subtract any term from both sides of the equation, and it will also not change it. Well, it won't affect the equation, I should say. It's a legal move. It's a legal move. That's what I want to say. You can multiply an equation through by any constant. Often we do that to clear fractions, which is what we're going to do in some of the examples we'll see today. And you can divide an equation through by any constant, of course, except for 0. That'll land you right in math jail. Never mind the fact that the universe will explode and the world as we know it will end. So we definitely don't want to divide by 0. So let's look at some of our examples that we have here. Okay, the first thing I'm going to do is I'm going to read my directions. And my directions here tell me to write the slope-intercept form of the equation for each line. So I have all kinds of different lines in here. If we see number 9 and 10, we have fractions. Oh, number 12 has fractions. My goodness, what are we going to do? Fractions, that's our favorite F word in math class, right? So if I just slide down, you guys can see that these are all different types of equations. They're all in different format here, no particular format that we want. So what we're going to be doing is we're going to be rearranging all of these so that they are in our favorite form, which is slope-intercept form. And we all know what that looks like. We use it all the time. So slope-intercept form of a line, that is our buddy y equals mx plus b. And the reason that we like this form so much, by the way, in case you were wondering, is because it easily allows us to see the slope and the y-intercept of the line. And when we can see that, we can quickly tell if a line, if a line or more than one line, if they're parallel lines, if they're perpendicular lines, or if they're in fact the same line. And those are all extremely useful things to know when we're talking about geometry, especially whether two lines are parallel or perpendicular. And so we really are interested in slope, especially in geometry. So if you forgot anything about the slope of parallel lines or perpendicular lines and all of that wonderful information, then you can go and watch my other video that explains about that. So what we are going to be doing is working all of these out and putting them in slope-intercept form. Now, before we begin, instead of saying put it in slope-intercept form, instead of saying make it look like y equals mx plus b, another thing that you might hear your teacher say is that we're going to solve for y. All right. And what that means is that we want to keep manipulating the equation until we have y on the left side and everything else on the right side. Okay, so we want our equation to look like y equals. So let's look at number 9. Now, first of all, I noticed that number 9 has fractions, okay? I don't like to work with fractions. So the way that we can easily get rid of the fractions is to multiply through by the least common multiple. The least common multiple is the smallest number that all of the denominators will go into, because it's going to be a multiple of that number. So that means that the denominator is going to divide evenly into it. And what that's going to do is it's going to give us an equivalent equation that's going to look a little different, but there won't be any fractions. And so when we go to move things around, it'll just be a lot easier. Our work will be a lot neater. You don't have to do it. In fact, sometimes you create more work if you do it. But in this case, I think it's going to help us out. So I am going to go ahead and I am going to multiply through, because remember, that's one of our golden rules here, right? So that was number 4. You can multiply an equation through by any constant. Completely and totally legal, will not land you in math jail. So when I distribute, because that's what I'm really doing, when I distribute that 6 to every term, I'm going to end up with negative 6x plus 5 plus 5y equals 0. Okay? Now for those of you that are going, what just happened? Okay? The reason that I ended up with that, let me just show you an extra step in between, little in between these, so you can see what happened there. So what really happened was this, okay? I distributed 6 to each term, so 6 times negative x is just negative 6x. 6 times 5, 6, so I multiply the numerators, and I get 30 over 6. Same with the next term, I get 30y over 6. And then, you know, any number times 0 is just 0. Any real number times 0 is just 0. So, that's what I end up with. Now, as you can see, 30 is a multiple of 6. So 6 divides evenly into 30 from both of these terms. So that's where this equation comes from. So this is the equation of the same line. These are the same line, but this one's in a much nicer form for me to move around. So that's why we did that. So I'm going to do what I've done in the other video in class, is I'm going to write y equals mx plus b on a separate sheet of paper, and I'm going to line it up to my equation, and I'm going to see if they look the same, and if not, what I need to do from there. So it looks like I definitely need to move these two terms, and I want the y's on the left, but I don't want this 5. So at some point, we are definitely going to have to divide. So let's start moving stuff. So in order to move these two terms from the left side to the right side, if I want to move a term from one side of an equation to the other, I must do that through either addition or subtraction. So because we are moving these to the other side, this is where we are going to perform the inverse operation. Because to get rid of negative 6x, I've got to add 6x. To get rid of 5, I've got to subtract 5. And whatever we do to one side, we've got to do to the other. So make sure that you write your steps and show your work. You know that all of your math teachers are telling you to do that, so just listen to them. Now, what I have left underneath here is I'm just bringing my 5y over, and on the right side, I now have a positive 6x and a negative 5. Okay, so we move those from the left side to the right side. Now I want to get rid of the 5. So multiplication is what's going on. And to undo that, I am going to divide through by 5. That's another one of my rules. I can divide through any equation by 5. And I am going to just bring my work up here. Okay, drew a little road map. These reduce to 1. These reduce to 1. And so what I am now left with is 5y, oh, you didn't see that. It's okay. Y, I'm just left with y. And this doesn't simplify any further, so I'm just going to leave it as 6/5 x minus 1. Okay? And if I compare this to my equation, my slope-intercept form of the equation, they match up. Okay, so I have y by itself, I have the slope, the x term, and then the y-intercept. So this is now in slope-intercept form, and this is our final answer. Now, if you notice, we did end up with a fraction, which is fine. You know, sometimes you're going to have a fraction in there. However, what we didn't have to do is when we were doing all of this work, moving it around, it's not a lot of work, it's 2 steps. But when we were doing this work, notice we did not have to mess with any fractions, okay? We just happened to end up with a fraction in our answer, which is perfectly fine, okay? Now, just because there was, we cleared the fractions in number 9, don't always be so quick to clear all of the fractions, because if you guys look in number 10, if I compare my equation to what I want, if I compare my, where'd my equation go? If I compare my equation to what I want, all that's being done to this y is I'm adding 1/3 x. So all I really have to do is move the x term, and everything else is already in the right spot. So in this case, I don't need to clear the fractions, because all that has to happen is I have to move this term to the right side. I'm going to do that by subtracting it from both sides. So these become 0, add up to 0. And what I'm now left with, if I just bring everything down, these are not like terms, so we're just going to write the x term first, and then the constant. Okay? So I'm done. That's it. So even though I had to move a fraction from one side to the other, I didn't really have to do anything with the fraction. So there's no point in clearing the fractions there. And that's it. That is our final answer. All right? Easy peasy lemon squeezy. Now let's slide on over to number 11. All right, this one is in a different format. Again, all of these are jumbled up because you guys need practice looking at what's there and kind of analyzing to see what steps you should take. So I have, I don't even have y on the left side, so that's a problem. And I don't have x on the right. That's another problem. And my constant is on the right, so that's okay. All right? So pretty much I need to get the x terms to, or term to the right, and I need to get the y term to the left, and then we're probably going to have to do a little division. So I'm going to do one step at a time here. I'm going to get my 3x over to this side. Those become 0. Now I have 19 minus 7y plus 3x. I know this looks kind of weird right now, but relax. It's not that bad. And I'm going to move my 7y to the other side. And this is not the only way to rearrange this equation. So if you have a different sequence of steps that don't break any of those 5 rules that we talked about, then you are more than welcome to do this in a different way. This is just the way I see it right now. So if you notice, I swapped these 2 terms because you can swap the terms on the same side of an equation as long as you keep the signs. Now the 19 is positive and the 3x is positive, so I want to make sure they're both still positive. Okay, but I just swapped the order. Instead of putting 19 plus 3x, I put 3x plus 19. Same thing. Okay, and then the last thing I'm going to do is I'm going to isolate the y by getting rid of that 7. And since multiplication is what's currently going on, what needs to happen is that I need to divide through by 7. So that reduces to 1. And I'm going to do what I did before to keep my work nice and neat. I'm going to bring this up here. Okay. And our final answer is going to be y equals 3/7 x. I can't simplify that, and I don't want a decimal, plus 19/7. And if I compare this to what I was looking for, we can see that it is in slope-intercept form. So that's perfect. So the slope is 3/7 and the y-intercept is 19/7. Not the prettiest graph to graph. We could. But luckily we don't have to graph it right now. We just have to rearrange it. So there it is. Okay, all done. And again, I just did one step at a time. I moved the 3x to the right. I moved the 7y to the left. And then the last thing I did was divide by 7. So let's scoot on over to number 12. Number 12 also has fractions. You're going to have to multiply through the entire equation at some point, so I'm just going to go ahead and get rid of the fractions right away. So the least common multiple in this case is actually, again, it's going to be 6, because before, when we were over here at number 9, we had 6 in the denominator. So if there's only one denominator, then just multiply by that number. That's kind of a no-brainer then. But 6 is the smallest number that 6 will go into, so that's why it worked out that way. Now, if we come over here, we've got two different denominators. We've got 2 and we've got 3. So 6 is going to be the number we want to use again, because it is the smallest number that 2 goes into evenly, and it is the smallest number that 3 goes into evenly. So it's going to be 6. So we're going to go ahead and distribute 6 again through this equation. And when I do that, I'm going to end up with -6 plus 3y equals 2x. Now again, some of you might be going, what just happened? Okay, well, let's talk about what happens. So if I distribute here, 6 times -1 is -6. 6 times 1 divided by 2 is going to become 6/2 y. And 6 times 1 divided by 3 is going to be 6/3 x. Well, 2 goes into 6, and 3 goes into 6 evenly. So when I simplify, I end up with that. And now I have an equation, or an equivalent equation of the line that I started with, but I don't have to worry about working with any fractions, which is super awesome if you ask me. And nobody's here to ask me, but let's just pretend. Let's pretend, okay? I'm going to compare this to my slope-intercept form. I'm going to line up the equal signs. That's the important part. Line up the equal signs. And this is not looking too bad. I've got my y's, I've got my x's, but this guy should be right over there. So we are going to add 6 because we want to move these 6's, and we're going to bring them on over here. Those add up to 0, and I'm going to bring down my work, and I have this now. And this is looking really, really good, really, really close. All that's left is to divide by 3, so we're going to go ahead and do that, so that y is all by itself. Divide through the entire equation. Not just the numbers that work out nicely, you have to divide through the entire equation. That's 1. And I'm going to bring my work up here, and my final answer is going to be y equals 2/3 x plus 2. And again, I can check that, and I can see that that is the form that I'm looking for. There you go. Okay. Moving right along, we have number 13. Okay, number 13. Again, this is nowhere near slope-intercept form. Nowhere near, not even close. So everything is on the right side. So the only thing we need to move is the y. Okay, so we're gonna move the y, and we're gonna have a little bit of a sign issue there. So we're gonna take care of that. So if I move the y over, that's gonna require me to subtract y from both sides. That's going to be 0 on that side, and on the left I am now going to have -y. I'm going to do what I did in a previous step, and I'm going to swap these. I want the x and then the constant. This is negative, and I'm not moving it to the other side, so I'm not going to change the sign. I'm just going to rearrange these on the right side so that it looks like the mx plus b. So I'm going to put negative 4x first. I'm going to put 14 second. Notice the sign didn't change. This term is negative. The sign in front of the term is the sign of the term. So if it's positive, there's nothing in front of it, or there's a plus sign in front of it. If it is a negative term, then it will always have a negative sign in front of it. So this is going to come down here. My 14 is going to go right there, so I can swap them. And then the last thing is we need to divide through by -1. Now, I don't want your other math teachers to get mad at me, but if all I have to do is divide through by -1, I don't actually write that step. I just go through and change all the signs, because what I don't want my students to do is to take time going negative divided by negative, positive, negative divided by negative, positive, or positive. Positive. Okay, that's too much time spent on something that you should be able to do in a split second, okay? So if the only thing that I need to do is get rid of the negative here, then I'm going to just go through and change all of the signs in my equation. And again, I hope your other math teachers don't yell at me, all right? But you don't even really have to think about it. This has to become positive, positive, negative. You just change all the signs. It's a completely legal move. It's really the equivalent of multiplying through or dividing through by -1. It's just that we're saving ourselves a little bit of mental energy doing it. Okay, and there is my answer, and we can verify that it is in slope-intercept form. Okay. Moving right along to number 14. This one's super close. There is no constant, which is fine. The only thing I have to do is divide by 3. And I'm done. Y equals -2/3 x. And we're done. All right, well, that's enough of that. Going up to number 15. I want my y's to be on the left, and they're not. So what I'm going to do here is take the opportunity to show you guys another little trick you can use with when rearranging equations. You can swap both sides of the equation. And the reason you can do that is because of something called the property of equality. All right, and the property of equality is very straightforward, because if A is equal to B, guess what? B is equal to A. It's the property of equality. Okay? So what that means is the left equals the right, then the right equals the left. So instead of moving things individually, I'm just going to swap both sides of the equation. So when I do that, I'm going to have -x plus 2y equals -8. Now notice I didn't change any signs. I literally just took these two terms from the right and put them on the left, and I took this term and I put it on the right of my equal sign. Perfectly legal move. It's called the property of equality. Now, you guys probably are already seeing what needs to happen here. Y's are going to stay here, x's are going to move, and then we're going to divide. So let's go ahead and do that. That becomes 0. So on the left side, I now just have 2y, and I'm gonna go ahead and save myself another step. Instead of putting -8 plus x, I'm going to put x minus 8, because I can swap these two, the order of these two, as long as I keep their signs the same. X is positive here, it needs to be positive here. 8 is negative here, it needs to be negative there. And now all I have left to do is to divide by 2 through my entire equation. So I'm going to bring my work up here. So on the left side I have y equals x divided by 2. Remember there's a 1 there. So this is 1/2 x. 8 divided by 2 is 4, and I have a minus sign there. So it's going to be y equals 1/2 x minus 4, and we're done. Beautiful. Beautiful. Ooh, this one's hard. And that's enough of that. Now you guys might be wondering, where's the x? Okay, well the x is not there, which implies that the slope is 0. All right, so in reality, it looks like this. But of course, this whole term is completely 0, so there's no need for us to write it. So it's just y equals -3. The slope is 0, and if you guys recall, if the slope is 0 and we were to graph it on our Cartesian coordinate plane, we would have a perfectly horizontal line down here at -3. I kind of missed the point there. It's okay. Anyway, so I missed the point, but just pretend that that was going directly through that point, and it'd be a perfectly horizontal line at -3. Okay, just FYI. Number 17. I'm going to do the same thing I did for number 15 because it's almost identical, right? I need to just swap the two sides of the equation, again using the property of equality. So I'm going to change this to be -x plus y equals 3. And I'm going to add x to both sides. I certainly hope you guys are getting the hang of this by now. We're going to go ahead and swap these two. They're both positive, so as long as they're both positive, we're good, we're golden, we're Gucci. I don't know if anyone still says that, but I said it. And that's all that matters. Slide over to number 18. Oh, another fraction. Again, I don't think we need to worry about clearing the fraction here because there's only one fraction and I don't have to combine it with any other term. That's the only x term there. So it's actually not going to save us any time to get rid of the fraction. So I'm not going to bother. So let's see. What do I want to do here? I can swap both sides of the equation. That is kind of my go-to because it saves us a lot of adding and subtracting of terms. Okay, so if the y's are not on the left, I tend to just swap them. That's just the way it works in my mind. And then you guys can probably see here that this is very much like number 10, right? We have the y, the x, and then the constant. So just like up here for number 10, we had the y, the x term, and the constant. If we just add that fraction over, then we're basically done. Okay? So if we go back here, I'm going to add the 7/3 x, 7/3 over here. It looks messy, but it's not because we're not actually doing anything with the fraction. And I'm going to go over here. So this is going to be -y equals 7/3 x plus 5. Take note that this term is positive and this term is positive. So when I write them on the right-hand side of my equation, they should both still be positive. And here we're in another situation where I've got to get rid of that negative. And while there's nothing wrong with writing out that you're dividing by -1, I don't waste mental energy on that. I just change all the signs. And there's my final answer. There's my final answer right there. Almost done. If you're still here, then good for you. Good for you. And if you're not, you know, can't help you. Hopefully you know your algebra. All right, so here if I compare this, let's not forget that we can always compare this to our slope-intercept form. So y's are in the right spot, constant is on the right, x's need to move. So that's what we're going to do. So we're going to subtract 2x from both sides. We're going to bring down our work, and I'm going to swap the terms on the right side to be the way I want them to be. negative 2x is first, negative 10 is after. I'm going to divide through by 5 because I want y to have a coefficient of 1. And that fraction doesn't reduce, this one does. So we will simplify it to just negative 2. And there we go. Slope-intercept form. One more, and we're out the door. Slide this over here. All I need to do is move my constant to the right side. And then I'm going to have to divide by 5 again. That's 1. And down here, again, there's a 1 right here. It's invisible. But when we have a fraction like this, you could leave it like that. It's perfectly correct. But I think most students prefer to see it this way. And then this simplifies. And there you go. That is our final answer. Okay, so just as a quick review, these are all different equations that you could see, all right? Some with messy fractions and things like that. So if you're asked to put it in slope-intercept form, that means you want y equals mx plus b. It means you solve for y. It means that y is on the left, everything else is on the right. And do not forget the 5 golden rules of algebra, okay? The 5 golden rules of algebra. If you don't break any of these rules, then chances are you are A-okay with solving your equations. And if you do break the rules, you know where you go.